Hello everyone. So again I am with this new video. We are continuing the chapter of tangents and intersecting chords. I think this is the fourth video in the sequence. So today I am starting the next exercise, the next topic, and the next topic is about the property of intersecting chords, and I will take it to the alternate segment properties. And I'm thinking in the next three videos I'll be finishing this topic. The playlist of these videos will give you the entire knowledge and the information about all the questions as such, which we have been doing for last 2-3 days in a row. So today's I start with this, the property I discussed with you yesterday, that if there are two intersecting chords in a circle and I name them as AB and CD, then the product of their segments are equal. So AP into PB would be equals to PC into PD. Please remember this property. So I apply the same property here. They're saying that PD equals to 9 and CP equals to 3. AP is 4.5. We need to find the value of BP, PA into PB equal to PC into PD. Simple property. So start from the point of intersection and go across the two parts of the same chord. And again from this and this, you need to simply take this in this format. Now put the value here. PA is 4.5, PB is not known, PC is, what was PC? 3 into 9, BP is 27 upon 4.5. Nine times 5, 9 times 3. So BP is 10 by 3 centimeter. That's it. It is as simple as that. You just need to recall the properties, and property will give you the entire answers very easily. So tangents, they are basically the applications of properties. So the chords are intersecting out of the circle. PA into PB equal to PC into PD. Now what is the value of PA? 30 upon 5, 6. Value of AP is 10. Value of PC is 4. Value of CD is X. 6 into 16 equals to 4 into 4 plus X. This is 96 equal to 16 plus 4X. So 4X equals to 80 and X equals to 20. The value of CD is, so remember, if I take like this, and this is circle, so the outer part and the complete. The outer, take it as P point, sorry. PA into PB, PC into PD. So how to remember? The outer part and the complete circle. The outer part and the complete circle. That's how you get the values of these chords. PA into PB equals to PC into PD. 6 into 16 equal to 4 into 4 plus X, that give you CDX equals to 20. This property was the property of the chord and the tangent intersecting out of the circle. PT square equals to PA into PB. I put the value of PT as 10, sorry, PA as 10 and PT is 12.5 centimeter. So I simply put the value, I need to find the value of AB, take it as X, PT square 12.5 square equals to 10 into 10 plus x. So you got 100 plus 100x equals the square of 12.5 into 12.5. Simply solve it to find the value of x. That will give you the right value of AB. So again, I will say to the focus should be on the application of properties. So the chord and the tangent are intersecting at point P. PT is the tangent and AB is the chord meeting at point P. I got PA into PB equals to PT square. A square of tangent equals to the product of the segment of the chord. A board question. Please see here this PT is like we got the values here. CD is 7.8 and PD is 5 centimeter and PB is 4 centimeter, and we got the values like this. We got to find the value of AB, take it as x. You see very carefully here a slight tricky question. PT is tangent. PDC is basically a chord extended to point P. This is the chord extended to point P. AB is also a chord extended to point P. They all are the chords. I need to combine the properties. First of all, I need to find the value of AB here. So the property applied, PB into PA equals to PD into PC. PB is 4 into 4 plus x, 5 into 12.8. So 16 plus 4x equals to, this is 5 times 12.8, multiply it, 64.0. It is 64 minus 16, 38, x equals to 19/2 centimeter. Simple, absolutely simple and easy questions for 2 mark or for 3 mark in the board exam. The second property, we need to find the value of PT. PT square equals to PD into PC. PT square is equals to 5 into 12.8. PT square equals to 64. PT equals to 8 centimeter. PT is 8 centimeter. Correct? I hope you understand this. So I got the value of PT square, PD into PC. PT square is 5 into 12.8, 64. Then PT is 8. The tangent is 8. Property, the square of tangent is equal to the product of the line segment of the chord extended to intersect the tangent out of the circle at point P. I hope the question is clear to you. Now this question is actually alternate segment question. Please see what does it indicates. So you got angle PAQ as tangent, AB is a diameter. So here ADB is 30. You see very carefully this PA is the tangent, right? This chord AD is making angle 30 at the circumference, and need to find the value of QAB. So you see carefully here, AB is tangent, AB is the chord, and the same chord makes an angle at the circumference. So this angle is 30 degree, right? Angle in the alternate segment is equals to angle between the tangent and the chord. So this angle is 30. Now these all are diameters. This angle is 90. This angle is 30. So we need to find the value of QAB. I got the value as 30. Then I need to find the value of PAD. Now this angle is 90. It's a straight line angle. 90, 30, 120. This gives you 60. Okay. So AD is 60. PAD is 60. PAD is 60. I need to find the value of CDB. I have found the value already. So this 60 here, 90 here, and 30 here. Easy question. Diameter always makes a right angle. At the circumference. Correct. So ये angle भी 90 है और ये angle भी 90 है. They both make angle 90 the circumferences. That gives us all the required angles. Then apply the alternate segment property. Alternate segment property is a very, very important property. You need to apply this question, this property. Again, see the next questions. Again, the property we are using is alternate segment. So you got tangent and you got a chord, right? And this gives you the property of alternate segment. Look very carefully. This TR chord is getting angle at the circumference here. So this angle is 30. This angle is also 30. Correct. This is 90. This is 60. I got the angle. I need to find the angle PRS. So 30, 30. This is the chord and the tangents. The tangent PR and the chord RS meeting at point R. This angle is equal to this angle and this gives you 60. Property is alternate segment. ROT is at the center. RT is the arc. RST is half the angle ROT. So ROT is double the angle of RST equals to twice of RST. This angle becomes 60. I hope you understand. So angle ROT is equal to 60 degree. Angle PRS is an alternate segment property equation. This angle is also equals to 60 degree. Angle QRT is 30. Angle RST is 30. I got also what my suggestion is that you try to find all the angles you can see in the diagram, applying the proper properties, and then you find out what is being asked. When you get the angles around this diagram, this gives you a clear picture of the questions and the all available angles with us in the property in the question. So making a diagram here, AB is a diameter and AC is a chord of circle with center O. So I make a circle. Please excuse my circle if it is not look like circle. AB is diameter and AC is a chord. So AB is a diameter and AC is the chord. Angle BAC is 30 degree. Angle BAC is 30 degree. The tangent to the circle at C intersect AV produced at D. This point is D. So what can I do now? This is the chord produced here. Now whenever I see tangent in the chord, it simply give me the idea that there should be something which is about the alternate segment. I should join BC. I need to show BC and BD equal. Angle BAC is 30. You see here the chord is BC. The chord is BC. This chord BC is getting angle BAC at the circumference, and this angle is in the alternate segment of the chord BC with the tangent also. So this angle DCB is 30. This angle is going to be 90. That gives us this angle as 60. Angle CBA is an exterior angle. So CBA is equals to BCA plus angle BDC, and so this gives you 30 as BCD, sorry, 30 as BCD, BDC is not known, and BCA is 60. That gives me BDC also at 30. So this angle also is 30. Now, so triangle BCD is an isosceles triangle. So BC equals to BD. That is the property of this question. A good question. A question that can be asked in the exam as well. I am taking up the next question. Again, they need to draw the diagram by us. Tangent at P to circumference of circle PQR is drawn. Tangent at P to the circumcircle of a triangle PQR is drawn. तो triangle PQR पहले हम एक सर्कल बना लेते हैं और उसके अंदर ट्राइंगल PQR बना देते हैं. At P to circumscribe triangle PQR is drawn. Its tangent is parallel to side QR. These two are parallel to show that PQR is isosceles. So I think this angle is theta. So this angle is theta. Take it as and the same angle is equals to angle Q. Ordinate segment property. So angle, so PQ equals to PR. Triangle PQR is an isosceles triangle. So there are two properties. Same angle is alternate for this and alternate segment for this. You can see the PR chord, beginning angle at the circumference, and this is the alternate segment, the entire segment, bigger segment with the tangent and the chord angle theta. This is equals to theta here. I hope you understand this very well, everyone. So I also expect that questions are coming clear to you. I use this diagram here to make the question again, to show you the question. A very good and fine question. You should try to understand that how property makes A very complicated looking question, so easy. So don't forget to apply the alternate segment property question here. You can see very well, let's say that two circles are smaller than the bigger circle. Center O of one circle lies on the circumference of the other circle, and CD is drawn tangent to the circle with center O dash at A. Prove that OA bisects angle BAC. I need to show these two angles are equal. That is what we are going to do here. So if I slightly make the diagram clear. Change the color. This angle and this angle is required to be shown equals to angle OAB. That is to be shown. Right. Now you see here, what should I do? I should first of all find out where are the equal angles and what are the equal angles, what it is all about. So you see here carefully that this OA and OB are basically the radius of the bigger circle, right? And also if you see again carefully here, OA OA is a radius of the smaller, I'm writing it here, OA and OB, radius of a smaller circle while OA and OB are the chords of the bigger circle, right? Now, since they are radius of same circle, I have written here, so they are equal to each other, correct? So, these two angles are equal. Look very minutely the diagram. These two angles are equal because triangle OAB so that's isosceles triangle. Then this angle and this angle angle CAO is equals to angle OBA. Angle CAO is equals to angle OBA, right? Why? Alternate segment property. That is where the same property plays a role, alternate segment property of the circle. So, angle CAO is also equals to angle OAB, or OA bisects angle CAB, because you got, so I got three angles on the whole. First angle, second angle, third angle. First and second are equal, first and third are equal, right? I changed this. OA and OB are equal, first and second are equal. Then OA is the chord, AC is the tangent. Third angle is equals to the second angle, and so third and first are also equal, and so OA bisects angle BAC. I hope this makes things clear to you. Right. Again, the question of alternate segment. So two circles touch each other internally at the point P. A chord AB of the bigger circle intersect at the other circle and in C and D. Prove that CPA and DPB are equal. We need to show these two angles are equal. So look very carefully. I don't have any tangent in this circle, first of all. A hint is given to you on the screen to you also. So what I do is that I draw a tangent. Name it QPS. Now this is a tangent to both the circles, the inner circle also and the outer circle also. Look very carefully. PB is the chord, QPS is the tangent, angle SPB. Angle SPB is the angle between chord and the tangent. This angle SPB is equals to the angle at the circumference. The bigger circle chord, it takes angle on the bigger circle. So SPB is equals to PAB, alternate segment property. SPB equals to angle PAB. Alternate segment property. Then we can take it as X, that will be better. Take the chord PD and the tangent PS and take it as Y, and this tangent and the chord takes angle here. This angle is Y again. They are the alternate segment for the smaller angle. Now look very carefully. So I write down like SPD equals to angle PCD. SPD is equal to PCD, correct? This is an exterior angle. Sorry, again this alternate segment property. All right. Now look again. Angle PCD is equals to angle APC plus angle PAC. Angle PCD is equals to angle APC plus angle PAC. So I write down angle, Y equals to APC plus X. So this angle is equals to Y minus X. Angle PAC is equals to Y minus X. So this angle is Y minus X. Come on to angle DPB. This angle DPB. So you can see DPB is Y minus X. Angle DPS You need to find angle DPB, right? The DPB is equals to the angle Y DPS minus BPS. This gives me again the value as Y minus X. So CPA is equals to angle DPB. It is as simple as that. So these questions are very easy if you keep applying the properties in such questions. There is a thing we need to do with these questions easily, right? I hope you understand the question. The next question, in a cyclic quadrilateral ABCD, the diagonal AC bisects the angle BCD. Prove that the diagonal BD is parallel to tangent to the circle at point P. I should make a diagram. Diagonal AC bisects angle BCD. Right? ACB and ACD are same. Prove that diagonal BD and a tangent at point A, remember this is a cyclic quadrilateral. So we need to prove BD is parallel to PR. To show BD is parallel to PR and angle ACB is equals to angle ACP. It is given to us ACD, ACB and ACD are equal. Now this question, I make an alert for you. From this question I am seeing that the property of tangents and property of circle are in combo, are in combination. So here you can see this angle is A, right? This angle is also A because these two are in the same segment. This angle is A. This angle is also A. They're also in the same segment. Now comes the point for the alternate segment. This chord is AB. It takes the angle at the circumference and this is tangent and the chord. This angle is also A. So these two are as well equal. That makes these two equal. That makes BD and this tangent at point A, this RAP, parallel to each other. It is as simple the question is. So again write down things here. So I got certain angle equal. I have shown you that AC is the bisector of angle C. Angle DCA is equals to angle DBA same segment. Then same segment. Now comes the alternate segment. Angle ADB equals to angle BAP. Alternate segment. So angle BAP equals to angle ABD here. So this angle and this angle is equal. So BD parallel to RAP, which is tangent at point A, correct? Because altered angles are equal. That is what we need to do in this question. The question which have the property of both the circle also and the tangents also. So I will take this question the last for this video. I will continue the questions in the next video as well. I expect and hope that you have learned the questions by now, how we are solving them and how the process goes to solve these questions. In the figure, ABCD is a cyclic quadrilateral with BC and CD equal. TC is tangent to the circle at point C and DC produced to point G. If angle BCG is 108, find the angle BCT, this part of the angle, and angle DOC. We need these two angles. Look very carefully. Angle BCG is not known, is 108. Right away we can say that this angle BCG is equals to angle DAB. Correct? So angle BCG equals to angle, this is the exterior angle property of a cyclic quadrilateral. So angle BCG Now, how to find the value of angle BCD? Now see, this angle BCD is actually the angle between tangent and the chord. It has to be equal to some interior angle. So I should make an angle between the chord BD and DC. So how can I find this angle now in this question? That is the point to see. This angle is 108. This angle is 72. Triangle BCD is an isosceles triangle. So angle CDB equals to 180 minus 72 equals to 108 by 2 equals to 54. This angle is also equals to 54. So angle BCG, children, BCT equals to 54 degrees. Then angle DOC is going to be twice the angle DBC. It is twice of 54. This angle is 108. correct. So I got the angle BCT, I got the angle DBC, I have the angle DOC. I think I'm stopping this video here. I'll take up the next videos in the further. Second time, practice questions till here. I'll take 10 questions each video. Practice questions every time I am giving them to you. And I hope that in the next 2-3 videos, I will be completing the entire chapter, which will give you a solution of entire concise chapter of tangents and intersecting chord. Please keep practicing these questions, and if you can get other questions from somewhere, try to solve those questions as well, as much as you can. Till then, wait for my next video. Thank you very much. Subscribe this channel, The Maths Box.